Hello everybody, welcome to another math video. In this video, we are going to look at identifying intervals of increase and decrease from the graph of a polynomial. The way that we do this is we just observe the graph looking from left to right, or in other words, as x is getting bigger. And we look at the behavior of what this graph is doing. Is it going up or is it going down? If it's going up, it's an interval of increase. If it's going down, it's an interval of decrease. So if we look at this graph, you can see here as we move from left to right, this graph is decreasing. So here's an interval of decreasing. This is a negative slope. The y value is going down, or if you just like it simply put, the graph is going down. Until we get to this point, this relative minimum, now the graph goes up. So now we are increasing. This is a positive slope and our y values are getting bigger. So we are increasing as x gets bigger. So again, as we look from left to right, it is decreasing here and then it changes to increasing. But we're not done there. We need to identify these intervals in terms of inequalities and in terms of x. So what we actually have to do is if we look at the interval of increase first, where does this interval of increase start? Well, you see right here, it starts right at the bottom point here. And this is at where x equals 2. We always want to describe our intervals in terms of x. What is the behavior of the graph in terms of x? Well, it starts when x is 2, and 2 is less than or equal to x. But where does x go off to? Well, x goes on forever and ever positive. It essentially goes on to infinity, and this graph is increasing between the values where x is 2 and infinity. So the inequality we're going to use is, again, is less than, but we do not include the equal sign with this because infinity is not an actual number we can be equal to. It is a concept, an idea, so we can't actually be equal to it, where 2 is a part of our graph, so we can be equal to it. So what this is saying, this interval is saying that the graph is increasing when x is between 2 and positive infinity. Again, notice there are two less than symbols showing that x is between those values. To identify the decrease, we're just going to do the opposite. What is the furthest most left point that this graph starts to decrease at? Well, this might be a little bit more complicated, but again, it's as far left as we can go. So it's as negative x as we can go. So it actually starts at negative infinity. And so negative infinity is less than x, which is less than or equal to, well, how far does this interval go? This interval of decrease, well, it stops at the 2 when x is 2. So what this now is saying is that this graph decreases when the value of x is between negative infinity and positive 2. Again, the equal sign is not included on the infinity side because we can't be equal to infinity, but it is included on the 2 side because that is a part of the graph and it can be equal to 2. So if we chose any section between negative infinity and 2, this graph would be decreasing. So those are your two intervals for increase and decrease.